Okay, so that took a while to find that. It was on the floor, of course. Here's my ground lead. Okay. Let's see if I can get the camera set up over here. Timber! Yeah, a few unfortunate things happened there. Just now. That's definitely not a good idea. I have a long microphone wire, which is handy because I have a separate microphone on my tablet now, and so I'm just setting this up, just figuring out how to make this work in the shop without hanging myself. And I very intelligently I have wrapped the wire, the microphone, around the hanger that's holding a hammer up high on my board here. And if I yanked on the microphone, I was going to pull that hammer down. It would have dropped, boom, right onto my bench. So, yes, I'm learning how to. Let's see. I really got to deal with this wire here now. Anyway, you got a nice view of the scope, that's for sure. Okay, let's get something going on there. So that's my finger. Okay, so I'm going to connect it right up to that spot. Seems to hardly affect the radio. Oop, what was that? What's that? That's fun. That's just... Okay, maybe this wire is not the best idea. Since it's pretty easy to clip onto, let me go straight onto it. Ah, that does seem a little better, doesn't it? So there's what we've got. There it is. I'm up on a fairly high band, so that's a fairly high frequency. Now how am I supposed to recognize that there's some extra components in there? Sure doesn't look like it, does it? Oh, that's just my scope not triggering well. That's about as good as it gets. Well, I don't see anything weird about that. Let's try a few other bands here. We'll just watch it. Output's getting bigger. What's going on there? It's just a triggering problem. It looks nice and clean, doesn't it? Wow, now that's the AM band. Looks really nice to me. But, you know, in this kind of format, you really could see a small unwanted component. but it sure looks perfect to me. I don't see anything here that. Okay, so it looks like the output. I'm going to have to assume the output of the oscillator is normal and working just fine. Let's go way up to the top. Now you can really see how it drops off. Because that's the last frequency. It's way down from where it was. I wonder if that's so weak it's affecting the operation of the radio. I mean, it's really not even showing up here. I think that's an important observation. Very weak. Or could it be the scope itself at this high frequency is interfering with it? Let's take it off. Doesn't sound any different at all. But I still have a short on the antenna. So I think that's an interesting observation in itself. The output of the oscillator is very weak at the highest frequencies. How that would affect the radio exactly, I'm not sure either. But obviously, if something gets weak enough, it's not going to work anymore properly. Okay. Next thing was, we'll put this right on the B+. And let's go on the other side of that resistor that we're on now. This is putting a fair chunk of DC into my radio, my scope. Okay, we're on the other side now. And this side, the frequency should be suppressed by that big capacitor. We should see nothing here. So let me change bands. Yeah. Even the highest frequencies, we see nothing. I'll make this more sensitive. It's very, very sensitive now. It's interesting how it's drifting around like that. Don't know what that is. But there's absolutely no signal sneaking out of this oscillator on this line anyway. Yeah. Okay, that's the AM band. I think we can be quite sure there's no oscillations leaking out of the oscillator up through the particular wire we're checking. I wonder what else could leak here. Let's see here. Well, we should just go on, well, you know what, there can't be any of these oscillations on the B+ line. It's also brought hard to ground by a big capacitor, so there just can't be any of the stuff on that wire. And where else could we get signals where they shouldn't be? AVC line, which I think was where we saw one. So the AVC is this green line. Let's see if we can get the scope onto the green line. Yes, quickly. Mr. Scope. To the green line. Green line can be found probably the safest place is the far side of R1, which is off the grid of V1. Grid of V1. V1 is that one. Grid of V1. V1 is a 6SK7. The grid, I can't remember. Never trust my memory anyway. Not for this kind of stuff. 6SK. Someday I'll memorize some of these. 6SK7 and the grid. No, what do we want? We want to the resistor off the grid. The grid is 4. Look at pin number 4 here. 1, 2, 3, 4. So that's the grid. So I'll take my scope lead and I'll reconnect it to the grid here. 1, 2, 3, 4. So this is a grid of the AVC. My scope's connected without any isolation, no capacitor, no nothing. I thought I saw a real nice signal on it. I show it on another video. You can actually see the signal on it. Looks like some hash there. It's a little noisy. What happened there? What? My lead didn't move off? The thing just went boop, boop, boop. I barely saw it. I was busy moving the camera. There, it's back again. What's that? My scope is set to AC and it shouldn't be showing any DC components, but it is. What the heck is that? It's definitely noise in there. There's some, look at, I can see there is some, looks like some kind of oscillation in there too. Let's try a different band. You can hear some teletype in there. There's no question, this is with the antenna shorted. I'm picking up teletype down in my shop. Wow, this thing is really sensitive. So what happened to the noisy signal? Let's put this on DC here. Now that should be moving up and down as I tune across these things. Hey. Appears to be no AVC action. No AVC action. Is that really true? Let's double check everything here. I should be on the grid of V1. I'm making some kind of mistake here. Should be on the grid of V1 so I can pick up the AVC voltage. Actually, I wanted to go on the other side of R1, and I didn't. I went right on the grid. That resistor R1 didn't show up right at the grid. It's somewhere else in the radio. Okay, I think I see R1 over here. So there's a wire that comes off that pin. Goes around to this resistor here. Okay, so if that's really the AVC line I'm on, that should be moving up and down on my screen. And I don't think it's zero where it is. See, there's a voltage there. Quite a negative voltage. Well, okay, so my scope is way at calibration. It looks like a couple volts negative. So I think we've got an AVC problem here. And we'll have to go through the AVC circuitry, and it's not a lot to it. See if we can pick up on something that's not right. Okay. AVC. Well, AVC voltage is developed right here with this little diode. Sorry, it's slightly out of focus, but this little diode feeds down through a resistor, and that capacitor, C30, should be the AVC voltage capacitor. And then I think I spotted there's a switch that when it's thrown far enough on this rotating tone switch. Oh, isn't that interesting? The tone switch appears to increase the capacitance of the AVC line. And it's hard to see, but there's a little, pops down here, comes out up here. There's just another capacitor, C29. So when you get this radio into the right position, you'll introduce C29, which will increase the, slow down the AVC. And you slow down the AVC, well, mostly you do that for listening to certain ham radio signals and stuff like that. You want the AVC the signal's intermittent, like on CW or on Morse code. And you don't want the AVC recovering between the tones. You want it to hold down the sensitivity of the radio between the Morse code tones, so the radio stays quiet the whole time. A fast AVC, you're going to hear it breathing. So that's a term they like to use for it. So we got to find this C30. Where's that 38? That's 38 there. Let's take a look and see. 39, C39. 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 50 microfarad electrolytic 25 volt. Maybe we gotta find this capacitor. And normally they are fairly large capacitors. Okay, where are you, Mr. Capacitor? Now, I think if I can find this resistor R15, I'll be able to find the capacitor, I think. So, R15 is how much? How much is R15? R15 is a 1, I believe it says 1 megohm. Right. Well, actually it looks like squiggle megohms. Here. I think it's 1 megohm. So 1 megohm would be like a brown, black, yellow. Isn't that what a 1 meg ohm is? Brown, black, yellow. So we look for brown, black, yellow coming off of this plate on V4. V4 is the 6SQ7, as we now know. Look at the 6SQ7. 6S. I can't wait to try this radio out against my big boat anchors. I think it's going to stand up really good. 6SQ7. No, SQ7, not SK. That's not going to serve us well looking at that. 6SQ7. Well, you know, there's two little plates. Do I know which one's being used where? Pin 4 and pin 5 are the two plates. The two little plates. Like, or diode plates. I guess I should say diodes. The two diodes. Well, we'll look for the one that's got the meg ohm hooked up to it. So it's either pin 4 or 5. Pin 4 or 5 on this tube here. So we're up in here. All right. Pin 4 or 5. You watch, if I don't say that enough, I'll start saying pin 2 and 3. Don't even do that. Pin 4 and 5. So what I'm doing is I have my my voltmeter here. I'm just going to look at pin 4 and pin 5. See if that clues us into anything at all. 1, 2, 3, 4. Wait. Hold the horses. Wrong tube. Wrong tube. Wrong tube, Jim. Come on. Tube number 4. Okay, so V4 is this guy right here, of course. There we go. Pin 4 and pin 5. 4 and 5. Still got it right. This is the one that's so hard to spot the key on the thing here. 4 and 5. The key on the tube. 1, 2, 3, 4. Well, that's interesting. It knocks the signal out in both cases. I see a brown, black, green connected up to this one right here. Brown, black, green. That's a 1 meg. Brown, black, green is 1 meg ohm. 1 meg ohm. What's wrong with that? 1 meg ohm to ground? I don't think so. No, it's 1 meg ohm down to this capacitor. Why that resistor is going to ground? Well, maybe this other one, maybe R14 is also 1 meg. It's R14 and 15 side by side on the schematic. Oh. I'm getting quite confused at my references here. R14 to 1 meg. Okay, so we have 1 meg to ground, and also here it is, 1 meg to a capacitor. Hey, look at that. You can't look at that. Okay. We're looking right up in here now. Okay, so there's 1 megohm resistors everywhere in here. 1, 2, 3 of them right here. Off of this pin there are 2 1 megohm resistors, so this must be the pin that we're after. And 1 resistor goes to ground. Boom. The other resistor comes over here and connects to this terminal. This terminal is the one that has the wires on it that goes down into the tone control, comes back up. And there's a capacitor. Where? I don't well, I don't see any capacitor. Just this one. This guy here that I put in. And that one is, wow, that's a terribly wrong sized capacitor. Okay, so that's the question. Is that capacitor really C38? That's a good question. So, you know, the way the set is wired versus the way it's drawn is, I find it so hard sometimes to easily relate the two. Could just be my brain's not good on that kind of stuff. So we're coming across, we're meeting up with this terminal, which is a very, very busy spot. And yes, it would be. The resistor comes down right in here, and it also connects down here, up there, up there, up there. So this is the, I don't know, splaying point, maybe I can call it that, for the AVC. It's developed here on this capacitor and then going out in all kinds of directions. So no problem, no surprise. So this is the AVC point. No, that's the ground point. This is the AVC point, and this capacitor gets involved when the switch here is closed back onto this wire. So this capacitor, that stupid 0.01 capacitor. And I'm not totally stupid. I turned on my soldering iron a few minutes ago in anticipation of finding something I'd have to solder. So if we change that, we're going to get a big change on this radio, I'm sure. And what we're supposed to do, 50, no, what was it supposed to be? C38. Wait a minute. Hold on, hold on. I'm going crazy here. See? Oh. It's easy to look at C28. Excuse me. Yeah, it's easy to look at 28 and think you're looking at 38. So C38 is... Wait. Hold on. Everything's gone wonky here. Where's my magnifier? Maybe I'm reading this wrong. Completely wrong. I don't want to read it wrong. Okay, it's definitely C38. C38. And C38 is a 0.01. Okay, that's fine. Okay, so that's the other capacitor that gets switched in. C28. Definitely C28. So C28 0.1 tubular. So normally, so this is how I'm reasoning this out now. Contrary to everything else I said, ignore everything I said up until this point. There's a 0.01 always sitting there, and the switch brings in a 0.1. So we know the 0.01 is sitting right there. Where's this 0.1? So the 0.1 comes off the tone switch, which is really interesting. I guess you could think of the AVC as affecting the tone with big quotes around the word tone, the tone of the radio. I guess that's what you could. That's why they would put it on the tone control. And then what setting on the tone control well, I guess when you get to short wave. And then you put it on short wave, that introduces a certain tonal quality and this extra capacitor. But we're on short wave this whole time, and we didn't see any AVC action at all. Which really can't be the fault of these capacitors, unless they're shorted. But they're not shorted because there's a voltage flying around on there. Well, let's find this C28 anyway. We'll find C28. And C28 is off of my head's coming apart here. It's a capacitor to ground coming off the AVC line after the switch. Okay, let me ponder this. I'm going to be quiet for a while, so I think I'll just stop the video and ponder this a bit.